I
Yeah,
think we should be live on YouTube. So, good morning, everybody. Peter and I are here for round three of looking at Python Unicode strings. Um, we had two streams so far already. We're going to continue to do these, I think, about once monthly. Um, the goal is to address the fact that Python Unicode or string data types don't store UTF-8 natively, and this leads to overheads in all kinds of ways, which we would like to try and eliminate. The first stream we did a lot of talking and thinking about the problem. Last stream we started going through the compilation of, well, beginning to change the Unicode data type. We're kind of working on a prototype now to see what the performance characteristics of doing all this work will be, because it's going to require changes to the Python C API, which will take a long time to actually play out. So if this is a change that the ecosystem should be considering making, we need to prove that it's worth doing, really. Does that sound about like what you remember us doing, Peter? Anything else
yeah.
to
So
think
what
about
we're
before we
doing
go in?
is renaming all the fields that change semantics. So anything that will be
Yeah.
computed lazily gets a lazy prefix or something like that. And then we need to go through all of the places that use those and change them to lazy or something else. And of
Yep.
course, AI could do that in a few seconds, but we also want to look at all the places uh, that do this
Yeah.
and see how this stuff is being used to kind of get a picture uh, of what we're changing.
Yeah, because what we're worried about is here's a diff showing the kind of work that we've done so far. Just going through this is the structure of Unicode storage for a stir object, and yeah, we've changed all these fields. Yeah, as you say, we're worried that where before these fags were computed eagerly, we made the decision, I think, if I recall, that rather than storing UTF-8, we were going to store the surrogate escaped representation instead, which is essentially UTF-8 plus some extra sequences that aren't valid in UTF-8 but allow Python to shuffle arbitrary bytes around. There's a PEP written about this, so I'm not going to go into more detail here. But then the other thing that by doing this, Python has a native format, which is what this kind is referring to, and we wanted to make it so that the native format is not calculated for now. So that's why we made everything lazy. And in the future, we would like to remove this other format entirely and just have UTF-8 if it looks like a change that's justified. So that's what we're trying to play around with. But first we need to, yeah, as Peter says, be careful about changing the usages of these fields that we're changing the semantics of to make sure that things continue to work. Hopefully, in the next hour, we're going to get to a point where we have a working compile, and then we can begin to play with it and see what happens, right?
Correct.
But depends how hard it is. Let's just go with make straight up. Might not run multi-threaded actually, because we'll probably get all sorts of interleaved output. So I think we just jump in and start looking through these call sites and work out what we should do.
Yep.
We might as well work from the bottom and go up. So in this function, it says, I'm going to have to refresh memory a little bit here. Unicode state has no member named kind. All right, we've changed kind. Sure. All right, this is in the implementation of this. And here we made a function to just... So this function is now returning the kind. We should compute it. We made a function to lazily compute the kind on demand, or the native format, and I can't remember what it was called. We'll have to see if we can remember it. I'm sure if we go back to our diff, we can find it quite quickly. It was this one, wasn't it? Fill data or abort.
Yeah.
Because the problem is that all of these existing functions don't assume that things can fail. And there are reasons. What were the reasons why we might not want this? I can't remember maybe we didn't want. I think the idea was that we would potentially head towards aborting if we didn't want to support the format at all. But I'm sure that will become clearer to us.
Yeah. So the problem is that this is like the representation that is always there currently in CPython.
Yeah.
So getting it is not something that can error out on existing CPython, and this API is basically the internal API that got exposed, and that's what people use.
Yeah, it was. Was it the? I'm trying to think why it could fail. Was it things like Unicode decoding could fail at this point? Maybe,
or memory allocation.
Or memory allocations, of course. Yeah. So there are a couple of reasons why this might happen. But yes, so in this case, we can just add.
So since it's surrogate escape,
fill data
I
report.
don't think the decoding can fail, but memory allocations can. Which, of course, on a modern system is...
Oh yes, because we were requiring the user to pass in a valid buffer, but I don't know whether we made a decision on whether we would validate it when the user sent it in. Or I guess we need to in some form. I'm sure we looked at that last time. Maybe we'll remember as we go. Right, let's keep going so I can save that one.
So we're storing the surrogate escape or surrogate passive, whatever.
Yeah.
Whatever it is, which will always decode to something, right? So what we'll need to do if the user asks for UTF-8, then we need to do the validation.
Mm-hmm. Yeah. Okay. Right, so we've done that one. Next one, structure Unicode state has no member named ASCII. So we have a few. This is in new subtype new. Okay. When this is going to be called when someone is creating a Python inherited stir, a subclass of stir.
Yep.
And what's the arguments that we've received? We've received the class, that's going to be the actual subtype, and Unicode is just going to be
a thing to copy from, the string to copy from.
Yeah, I suppose so. Oh, hang on. Yes. Right, yes, because this is done to new, that's taking the type and all of the arguments like encoding or errors, and then we get to a point where we create a Unicode. So we create a real stir doing all the decoding, and now we pass that object to the subtype constructor to fill in the subtype. So we actually already made one that we know is valid. And then we're now constructing into the subtypes instance. So we need to do more work here to fill the subtypes values. So I'm assuming somewhere we're going to be allocating. Yeah, we're going to allocate the subtype. And now we're populating all of the Unicode fields in the subtype before the subtype's new implementation is then going to fill in any state that it holds for the subtype, I guess. So we just need to make sure that this is all valid. It's probably okay for it to be all lazy and everything at this point, I guess.
Well, if we are calling PyUnicode kind, then
it's already done. Yeah. Do we need that? That's set. That's from the original data.
Yeah. So we probably want to change this so it's lazy as well. But for the initial implementation, let's just make it lazy.
Or eager, you mean?
Lazy. Eager, yeah.
Yeah.
So on that line, just set lazy kind to kind.
Yes, because this is going to eagerly initialize this one, And then, so we have all the data. We know it's all valid data.
So just change time to lazy time.
Yeah, I'm just trying to read the UTF-8 stuff going on here just to follow. So yeah, I agree with you. We can do this here. We had lazy ASCII as well, I think. We changed. Oh, Peter's sound could be louder.
Oh,
all right.
Okay. Do you want to do that?
I can hear you fine, so why don't I modify the OBS settings? Thanks, Asan, for letting us know.
Maybe you say something for reference as well.
I think let's try that. Can you say more, Peter?
Yeah, here's me saying something just to check the sound level.
I think we're pretty level now.
All right.
So that's good. Perfect. Great. So let's go back. I've just realized I can't see the stream chat very easily, so I don't want to mess with settings though and break OBS. It's been fickle with me this morning. Okay.
Yeah, I have the stream as well.
Are you able to have the stream? Have you got space on your monitor, Peter, to fit the stream chat up in case anyone else asks questions?
I just need to put it in a place where I see it and notice something changing there while I'm looking.
That'd be perfect.
That's the biggest problem. Yeah.
I mean, if we're a little slow to answer questions, I think that's forgivable. This is the first time I've managed to get my Linux dev box to do OBS. The last two times it's been like a rush to get the macOS device to do the stream at the last minute because I couldn't quite get OBS configured. I'm still having like random teething pain with OBS, but next time maybe I'll have the stream chat up properly so that I can see everything and do and chat as well.
Is there a setting in YouTube where you can get like a little bell sound when somebody posts a message?
Oh, good question. Oh, or there's a pop-out chat here. That will do. Okay. You've asked me a question that's made me discover exactly what I need. All right, we're good. I've got that up on the side now. I'll just have to try and notice it. But yeah, I can't see a way to make it notify. There's probably one. Let's go back to the code. See if we can remember what we're doing. Right. So that's not changed. The UTF-8 stuff is potentially a concern. I'm sure that
it's all eager now, so it's all filled up right now. So we just
we renamed that function though, didn't we? I think we called it. We called it. No, that's been changed somewhere else. UTF-8 length. Here we are. We changed it to set surrogate escaped length, which we did because it's not assumed to be UTF-8. It could be a surrogate escaped sequence. I was looking at this again and I was like, oh, that's a really long name. It'd be nice to have something nicer, but I think we'll just live with that for now.
Yeah.
So I mean, surrogate escaped.
It will be a very easy change later, so let's be explicit.
Yeah, I agree. So, okay, we can go back to where we were. So this is now set surrogate escaped length, and this is presumably set surrogate escaped. Yeah, here we are.
Yes.
And then what happens? We look at kind, we fill in kind, which is, okay, this is going to be
kind is the number of character in the internal representation. So we get the size of each code point. And then if it's ASCII only, compare the UTF-8 representation with the Latin one.
Yep. And that is because in this code path, this is going to end up having the old semantics where the native data format, the 1 byte, the 2 byte, or the format, which is what we're looking at here, is eagerly filled, and then the UTF-8 data in this subtype is not filled yet because it's only in the ASCII path is it being filled, where we know it's ASCII, so we're just reusing it, and otherwise it's leaving it to go lazily, which I think we left to function as it was, right? I'm trying to remember now. So the export function that will be interesting is Unicode as UTF-8 and size, where we still have the state where we fill in the UTF-8. So I think it's okay if we go in this direction. So I don't think we need to...
Well, yeah. So in this case, we have the origin or the internal representation already. So
potentially, but this Unicode object, I guess, could be in the same state where it's not got well, it doesn't yet necessarily because of the changes we've made. You're right. In the future, we should always have that UTF-8 buffer. I think now the changes we've done should just flow through and work. And
that's a good question, though. I don't think we should always have the surrogate escape buffer. Like if the user creates a string from the old internal representation, we should keep that.
For now,
otherwise we'll get lots of overhead on creating the existing ways of creating strings, and we don't want that.
Okay, so in which case we want to have the possibility to lazily create the surrogate escaped buffer, and that looks like it's fine then. This code is, for now, designed to flow through the existing encoding. What we should probably do, let's leave ourselves a to-do here. To-do if the surrogate escaped buffer is set and the native format is not, use that instead of the native format.
Well, we should copy. Well, if the surrogate escape buffer is set and the native format is also set, then we should just copy both, probably.
Yes. Yes. We could copy into a new allocation for the for both.
Or choose one.
So let's rewrite this. I guess we want to do both ideally. So if the surrogate So it's this, isn't it? We can copy the surrogate escape buffer if that's currently present. We don't want to eagerly create the native format if it's not set. I wonder, do you think there's an optimization here where if you're creating a Unicode subtype, or for an optimization for existing CPython, I'm thinking, looking at this code, where if you're creating a subtype from a Unicode object, and that Unicode object already has a UTF-8 buffer populated, which is currently done lazily in CPython, right? Then when creating a subtype, that buffer's not being copied in, it looks like. So I wonder whether there's an optimization for existing CPython which could copy that UTF-8 buffer already if it's present on the original object, this one that comes in, as a good thing for present day.
I mean, there's always a trade-off between speed and memory, right? If you copy the
and
buffer
you're duplicating the memory, sure.
You're duplicating the memory. And in case that's never used, that's just wasted memory and wasted effort to copy and to copy it
Yeah.
over. If you
Yeah.
will
Okay.
use it later, then of course it's worth it. But you
Yeah.
never know.
I think that makes sense. We can play around with that another time, perhaps. There's a possibility, but it's not
I
obvious
mean,
then that it's
we
a
could
win. I take your
always
point.
we could also do some more elaborate scheme with sharing the buffers, like reference counting them. Uh,
Yeah. Uh,
which
I
would
mean, we
probably
spoke
be
about that previously, right? How
uh,
it would be nice to have things like custom destructors and reusing buffers for things like even reusing buffers from Rust as well.
yeah.
And that presumably that would be a little bit of reference counting op to reuse a buffer that came from the parent object might be useful here. But okay, that's something that we can maybe pick out in a future stream. Uh,
Far future. Let's stick
yeah.
to easy changes.
I'm just going to write it down here for now, and then maybe we can move the note somewhere else in a bit. So we could reuse the Unicode buffers from Unicode to avoid memory duplication. Okay, that seems like enough focus on this particular function, I think, for now.
Yeah.
I think we've done that. Let's run make again and see what happens. Where do we go now? We're still in this function. PyUnicode length is a macro that we've broken because I think we called it lazy length. Did we? PyASCII object has no member named length. Let's go check what we did. Yeah, we called it lazy length. We called it lazy length because this is the length of the native format, and so we might be calculating it lazily. Yes. So this is inside Unicode object.c. Probably we want to. Well, how many uses has this got?
Rename it to like.
Well, I guess we've got a couple of different possibilities, haven't we, here? Like, maybe we want to make this eagerly fill the data if necessary, or maybe we want to...
Yeah, let's do that for now. That sounds good.
Yeah. That seems unfortunate because I'm guessing... What does PyUnicode do? So we've already got this one.
Ah.
Oh, and this is the R value. This is writing it. This is a place that we can assign to. So we don't want to change this to a static inline function. So we could just rename this to lazy length, I guess, and make it a place.
Yeah,
that seems like the way to do it, right?
Yes.
Yeah, we don't need to copy this. We can just replace it. And then I guess we'll still use the exit. We won't do a bulk find and replace. Let's just change it as we get to it.
Yeah.
We can remember that one. Cool. So we've now got lazy length. Hash was always lazy, so that doesn't need to change. I think everything else we've already changed.
Yep.
Okay, so that's probably good. Let's just scroll up. So we did this one. Now this is a different function now. We deleted PyUnicode UTF-8. We called it surrogate escaped.
Yep.
So we're going to just have to change it in all three places, I think. And so we're Yeah. I completely misread that as mem copy. I was like, we're in a function called equal to UTF-8 in size, and we're doing mem copy. No, we're doing mem comparison between some. Ooh. But if this is equal to UTF-8, then if it's surrogate escaped and it's not valid UTF-8, we could fast path
Then you're
here.
passing invalid UTF-8, right?
Well, I think it's okay to do a memcomp because it will just always fail, right? If this is if we're getting a UTF-8 buffer to compare against, and this is not UTF-8, it doesn't matter because this is just comparison. It will just never succeed. So this is probably okay for now. It's not unsound, but there's maybe a fast path. If not valid UTF-8, which I think we set a flag, but I can't remember whether we made the flag lazy.
I don't think we have a flag yet.
We definitely added one because I remember we needed it at some point. It's like valid UTF-8 or something. It's valid UTF-8, but I can't remember where we set this. We haven't set it anywhere yet. So we haven't made the decision on the semantics of the flag is the answer. We can't we can't use it yet.
Right.
But so yeah, we can. I guess if it's false, then let's leave it until we know whether the flag's lazy or not. Okay, so that's okay. I think most of these errors are from this call site, so let's jump and remake. Now we are here. This is lazy length again. That looks fine. It looks like we're assigning to it.
Yep.
Okay, up we go. This is now pi bytes from string and size. This is so this is where we want
so this
to
is creating UTF-8
careful.
including bytes object, so we will need to fill the data in. We just do surrogate escaped and UTF-8.
That yes, but we want to guarantee that the output is UTF-8. So do we need to do something about the surrogate escaped handler here? And raise a decode error if it's not good. Because the output has to be valid UTF-8, I think, in this function.
So this is checking. Oh yeah, right.
That's checking if it's allocated, and then it's creating a new bytes object from the byte sequence, if it's existing.
Right. So we also need to check if it's valid UTF-8, right?
Yeah. So that's where this is valid UTF-8 flag that we were just looking at is interesting, but.
But we also need a function that fills it in if it's not.
Yeah, I think we didn't do the constructor yet. Is the thing I remember. Is that like a to do at the bottom of the file? I have a feeling that we put the function somewhere. Hang on, let's look at the branch diff again just to refresh our memory on this.
So the thing is, we can't have just one flag for this is UTF-8. We need to have two flags because this is tri-state logic. Either we know it's valid UTF-8 or we know it's not valid UTF-8, or we don't know yet.
Yes, I think. Right?
Well, so that depends. We need a function to fill in this flag, and then we can check it.
Yes. Yeah, let's think about that. I think you're probably right, because here's the constructor we wrote last week, where we just take some buffer and we put it straight into our surrogate escaped location. But Then what's going on is we're not setting that flag. We're not checking whether it's valid UTF-8. So you're right. That's indicating tri-state. Now we could. What else could we do? We could check here, but that's quite expensive at the boundary. We could have a constructor which guarantees it's valid UTF-8, like PyUnicode from UTF-8 or whatever, and then that the user can assert, like maybe it's unchecked or whatever, which would be a fast path. But I guess you're right. It feels to me like for just constructing from arbitrary data, it's better to just take the data and not be confident about it, rather than incurring that cost at the boundary, right? So
right. So what I think we need is an internal function that tells you whether it's UTF-8 or not. And if we don't know yet, it'll check.
Yeah. So we're thinking that this might need to be 2 bits then to be tri-state.
Yes.
I'm also just trying to think whether any of the other flags would tell us that information on whether we know, whether there's a bit somewhere else that would already tell us whether we have done the calculation. I don't think so, because lazy kind and lazy ASCII are both related to the ASCII format. And the only other thing we set... Hello, Ricky Pandy. Thanks for joining and watching us experiment with Unicode objects today. Yeah, I don't think there's anything else in the Unicode objects that we can use, so we'll need to just make this tri-state for now.
But let's not do that right now. What we need is a function that tells you whether the UTF-8 is valid. And that internally you'll need to check if it already checked or not. But right now we're going through like compiler errors.
Yes, so we just want to resolve that and make that symbol undefined for now.
Yeah, just make it static. Leave it to the linker error.
Yeah. So PyUnicode. Would you underscore it, or what's your naming convention you like to have for an internal function here?
Yeah, underscore.
And keep it like this, so it'll be is valid UTF-8, just like this.
Yes.
Just like this for now.
Yep.
And then we can just use that right here. So, hang on. Yes, so how is this function working? This function is now checking.
If it already has a UTF-8 buffer, it makes bytes from it. Otherwise, it'll
do the encoding. Yeah.
Do the encoding, yeah.
Which, and so for the moment, this encoding is going through the existing native format. That is fine because we'll lazily allocate it here. In principle, I guess we want to do something smarter where we decide which format we already have filled and decode from that. So I guess there's 2 things we can do. Well, first we need to rename this UTF-8 to surrogate escaped. And then we have our new... So if we have our surrogate escape buffer and it's valid UTF-8, then we can do the eager thing. Otherwise...
when you're changing the if, also add in the curly braces around the body, please.
Oh, yeah, is that... do you prefer the opening brace like that, closing brace there?
Yep.
Mm-hmm.
Thank you.
That's quite all right. And do you prefer this indentation as well for the function call?
Whatever.
That's not as big a change.
The C style guy doesn't really say anything, I think.
Living in Rustland, I just defer to Rust format for everything. I hit save, the entire file reorders itself to hit Rust formats. decreed way that everything should be written, and I don't think about it at all.
Yeah.
There is like C formatting tools, right? But I guess it's just an
Well,
intractable
there is
problem to think
another way
about
to get
formatting
to the point
CPython.
where there's another way to get to the point where you don't have to think about it, and that's just to not care.
Yeah, okay. Let's not do that. That feels like the wrong direction to go. Right. Okay, so where were we? We can then big to do here. If the surrogate escaped buffer exists, consider decoding from that, I guess is one. I guess there's potentially an interesting question here about this is valid UTF-8 as well, right? Because if this is going and checking if this is having to do the decoding work, if you like, when it's doing this check right there, it could generate the exception and return it eagerly rather than going through and doing the decoding again to return the exception. But that's going to make this function a lot messier, because then it won't be a bool, it'll be like a tri-state return as well, where it's like, I already know it was not, I know it was, or I've just tried and I've failed to decode, would be, I guess, the three possible return values, which feels a lot scarier. So I guess we don't want to do that.
Yeah, we probably want a function Unicode is invalid UTF-8.
Right.
Which will tell you it's invalidated. And also, probably Unicode as valid UTF-8 might want to guarantee that the UTF-8 representation is available.
Oh, so you could take this check out, basically.
So you could check that out, yes.
But
I'm not sure if we want to do that, so keep the check in.
Yeah.
So for now.
So returns whether the surrogate So what did you think about the possibility of, if this hits a decoding error, surfacing it? Or do you think this should always swallow its decoding error?
Yes.
You think it should swallow it for now?
Yeah.
Okay.
It should swallow it, but it should set the invalid UTF-8 flag.
Yeah. Okay, let's do those semantics for now. Okay, and then we've discussed that we could decode from the surrogate escaped buffer, but we won't do that now. That's an optimization that we can play with later. Right, let's see, where are we? This is probably, okay. Unicode as UTF-8 in size, we're probably going to have the same problem here. We want to return a UTF-8 buffer. This we know we want to return a decoding error if there is one. That's currently created by this function, I think. Let's look at this. This fills it, or errors.
Oh, that looks useful.
Yes. Which seems okay, but this is going to produce it from the native format. We might have the surrogate escaped buffer and need to do something with it.
Yes.
So we probably have a second clause here, right? Which is else if Unicode. So this is where we had this is valid UTF-8. Oh, it must be too low down. Let's just put it up here for now. Let's think about this. So if that is valid UTF-8, then we're okay.
Yep.
So that would be what, return 0, I guess.
Yeah.
And that's not going to, and if it's not valid UTF-8 and we didn't produce an error, we need to somehow surface a decoding error here, right?
I wonder if this should be Unicode ensure UTF-8, or we should just change it to Unicode ensure surrogate pass.
Oh, interesting. Yes, and then we're not having to change.
Yeah.
Well, hang on. How many call sites are there? There is only one call site.
Oh, there is only one call site.
There's only one call site, so we don't actually even need to keep this function. We could just inline it straight in if it makes the thinking simpler.
So I think this is the function that fills in the buffer.
Yep, which makes sense.
And this one shouldn't do the validation.
I would be tempted to agree. So we can call this ensure
surrogate. What's the term we're using? It's probably not the right term, by the way. Surrogate escape.
Yeah, I will have to think about what we want for that. But it'll be easy to rename once we've done the work. Okay, and then Unicode fill UTF-8 is going to now be called. Ooh, interesting. So hang on, where's the call sites for this? There's 2. No, that's a forward declaration. There's 1 call site. Okay, fine. Because this, we can change this function, right? Because at the moment, this is now going to fail to decode.
No, this should fill the surrogate escape buffer. And it should also, well, it can error out because it can fail, the memory allocation can fail.
Yeah. Okay.
And that function should set the flag because it will know whether it's valid UTF-8 or not.
Yeah.
Maybe.
Okay. We'll have to think about this. So we currently have specialized functions for decoding UTF-8 for different byte kinds, but we want to change these to be decoding for surrogate escaped instead. This is going to be, hang on, but that's probably going to be possible with the error handlers, right? Let's just go into these.
Future, yeah.
Sorry, you say we should skip this for now?
Yeah, I think we should skip this for now. We're just getting the shape of the private API together.
Okay, so these encoders should use surrogate escaping. Yeah, and that will be good enough. Right, so and then that has the nice property, as you say, that if it's succeeded in here, where does it do this? It builds a, how does this work? It builds a Oh, it builds a buffer. It decodes into it, and then it copies the data out the buffer. I see.
Yep.
And yeah, okay. And then it. Oh, that's interesting. Fine. And then we could go further, as you said. We can do Unicode state, Unicode equals 1, because we know this.
Well, right now, yeah.
Yeah, and then fix me when this function changes. Good morning, ECNIRP. I'm not sure how to say that. ECNIRP. I hope that's said right. Thanks for joining us this morning. We're having fun with Unicode encodings inside CPython. Some way to go before we get a successful compile, but hopefully we'll get there in the next... I've got about an hour and a bit left this morning, and it'd be really cool to get a full working compile on this function.
Well, we're
right.
figuring out how exactly the pieces should fit together.
Yes. Okay. When this function changes to accept surrogate escapes, this flag should be conditionally set. And so at the moment we can set this flag here, but we might not need to. Read my name in reverse. Prince, I think. Well, welcome, yep. Prince, then. Okay, so we're filling the surrogate escaped buffer. Let's go back out to where we were using that. That was inside Unicode ensure surrogate escaped, which was here because we're trying to return out the UTF-8 buffer if it's available. So now we can use our new function, Unicode is valid UTF-8.
And I guess if it's not valid, then we need to raise an error.
Yes, and so this is where we need to have a function which goes through the surrogate escaped buffer and attempts to... Actually, this is, yeah, we don't want to just use this check here. We want to do something different. We want to go through the buffer, the surrogate escaped buffer, and ensure that it's valid. So I'm just going to...
Okay, so if we know this is valid UTF-8, then we don't need to do the check.
Yes.
Otherwise, this is the place where we want to do the check. And we probably want here to go through the whole buffer and validate UTF-8.
Yeah.
Even if we know it's invalid, just so we get the error out.
I agree. So I think we want a function... For now, it could be... I mean, we could make a new Unicode ensure UTF-8, right? Which does the same thing.
Right.
Which might
yeah, Unicode ensure valid UTF-8 sounds like a good function to have.
Yeah, okay. Let's just go with that for now. We'll forward declare it. Unicode ensure valid UTF-8. And this will returns... Do you prefer bool or int return, by the way? I wrote the other one with bool.
This function should raise a Python exception on failure. Which
yes,
means, like in the new API design guidelines, that it should return either a PyObject star, which is null on error, or it should return int, which is -1 on error.
Okay, so, okay, right, because this one was infallible, bool is okay, is the difference?
Yes.
Because it's just true, false, whereas this So returns -1 and raises it's presumably a Unicode decode error on failure.
It could also return like raise a memory error.
Okay.
So
Let's just go with sets an exception. Will it ever use a memory error because it's going to presumably
yes, because
just
it might call Unicode ensure circuit escape first. Like if we don't have the buffer yet, it'll attempt to fill it.
Oh, I suppose. Yeah, I was assuming we might just call it. But, oh, yeah, it probably does need to call that other one. Yep, that makes sense.
I mean,
Yeah.
not for this call site, but generally it should do that.
Yeah. Okay. Well, we could do this. Yeah. Okay. So we could fill this function in roughly, or not. No, probably not. Not quite yet. Okay, we'll come back to that. So if this function is -1, we want to do the same thing.
Yeah.
And
less than 0 is a better check here. Okay. Idiomatic now.
Okay, that's interesting actually, because I haven't quite decided on downstream in Pio3 handling these int returns from Rust. I can't decide whether I should be checking for -1 or checking for less than 0. And if you're saying check for less than 0, that I'll do that.
So less than 0 seems to be more idiomatic in modern code. It also needs to check just one bit on architectures where that matters.
Of course. Whereas otherwise, checking for -1, you have to check the whole value.
Yeah.
And so it's
it
potentially more efficient.
In terms of clock cycles anywhere, but there's no way it could be less efficient.
Yeah, absolutely. Okay, so we'll go with less than 0 as the canonical way. I'm sure that in Pio3 we use a mix, so I'd be keen to clean that up.
Yeah, CPython also uses a mix, as you can see.
Yeah, yes, but I think probably CPython is probably 10 or 100 times larger than Pio3 in terms of code base, so it's more tractable to replace Pio3, whereas it's probably just going to be a gradual migration for CPython. Okay, so if we get to this point, we now know that we have a surrogate escaped buffer which is valid, so we can use our new functions. Oops. And this will be the buffer, the pointer to the buffer, and it's UTF-8 buffer. Now we know this, so that's okay. So that function is solved, barring the implementation that we didn't write. Okay, how are we doing? We've got still quite a lot of errors. Let's work out what we've got. Okay. This is probably a macro expansion somewhere up. We just need to work out where it's gone wrong. Expansion of that.
Whoa.
Probably have made something unhappy by changing. I suspect we've changed a name or something, and it's broken a compile.
Look at first there. Parameter declarations.
Oh no. I haven't.
Go to that. Line 4167.
Oh.
Missing semicolon. Welcome to see.
Okay. Yep. Great. That's a bit more tractable.
Used but never defined. Yeah. Just lose the static for now.
Where? Sorry.
Oh,
Oh.
the last. Just lose the static. We don't have the function yet.
Okay,
Okay,
fine.
yeah.
Static doesn't technically matter anyway, right? Because CPython's compiled with symbol visibility hidden. Or is it?
No, static means it's local to the compilation unit, so it's not visible outside of the C file.
Isn't
Like
is
it.
that true even if it's not in a header? I guess it doesn't matter, does it? So yes, it matters.
So if it's in the header, it needs to be defined in that header, and that means each C file gets a copy of that function.
Yeah.
It's shared in any way.
So I understand static in that context because it will. If you had non-static symbol in a header, it would conflict because that symbol would be present. Okay, and now maybe I'm seeing exactly the point that the symbol exists outside of this unit if it's not marked static, so it should be. Good morning, Watertar. We are working through Python's Unicode data types. Currently store a variety of different fixed width encodings. We would like to store UTF-8 because it makes interchange with Python and Rust and Python and text formats and all sorts potentially a lot more efficient. But there's reasons why that's hard, and so we're prototyping how it might work. Yeah, okay, so right back where we were. We are back to errors on PyUnicode UTF-8 length. PyUnicode has surrogate escaped memory. Interesting. So this is...
Oh, we added that, didn't we?
We must have already replaced this. I think it probably used to read has UTF-8 memory. And would have just checked that we're not sharing it with the ASCII buffer, I think.
Yep. Yes.
And so I'm just trying to understand what size of here. Size of the string in memory in bytes. Oh, okay. So it's counting how much memory is allocated by this thing. So that seems fine.
Yeah.
We can just replace this with surrogate escape length.
Yes.
And we're counting then the buffer of the allocation.
Add the curly braces again.
Oh, yeah, of course. We do have one other interesting thing going on here, though, which is that we probably want to avoid calling PyUnicode kind here and allocating a format from within size of. But we can leave that for now and just to do, I guess. PyUnicode get length will also fill the data. So this and this are problematic in that we probably don't want to have to make an allocation if we're just counting size.
Right.
So did we have
but I guess is compact as so if it is compact ASCII, we don't care because that'll be shared.
Yep. Oh, and it's actually true about is compact as well, right? Because
no, if it's compact.
I'm
if
fairly confident.
it's compact, then we need to have the buffer filled in. Yes.
Yes, the buffer's already there. And I think if it's compact, I think we decided that for this code path we're going for, the buffer is always an external allocation. So it's never. So these cases never hit the new code paths that we're writing. So this is the only code path where this is the base object, size of PyUnicode object, where it's got the buffer. Then this we've already changed. No, this is already true. If there's, yeah, perfect. if there is an allocated buffer for the native format, then it does the counting, but there's not going to be.
Right.
So it's already correct. That's cool.
Good.
I must have got a typo. Yes, I do. Okay, now this... Oh, that's just invalid syntax. Where are we now? We are... Oh, we called it with the wrong type. We immediately cast it.
Yeah.
I think we changed this. From a macro.
Yeah, from a macro to a static inline function.
Where's the diff? Oh, because it was just Unicode data any, which was a place which does the cast. Oh, we must have just done this wrong, because that is needing a Pi object in anyway, right? Like Unicode object cast is taking a Pi object. So
Yeah.
we... Hang on, where did we use
Now, if
this?
it has the underscore, it's internal, so you're supposed to pass it a Unicode object. And it just does the cast with an assert.
Yeah. These all seem... Oh, you mean we could... Well, there's other ones in this function which are already here that are taking Pi object. Okay.
Yeah.
Well, would you recommend we just do the cast backwards, or should we change the symbol?
Yeah, just do the cast backwards.
We'll just do the cast for now. Okay. And this is now surrogate escaped length here.
Yep.
Yeah, which makes sense. I think we changed that later. All right. Now we are looking at something doesn't make sense to me here, because op is not a... This is probably just meant to say Unicode. I suspect that was a typo from before.
Whoops.
And now... okay. We changed
Now
this.
we're back again. All right.
That's now like that. And we called it set lazy length. Oh, we didn't. We called it lazy length. And it's still a place. Okay. So that's fine. Okay. Now Unicode is singleton. If the ASCII length is 1, fine. uh, because it's always previously set. I guess this is probably the case, that if it's one of the ASCII singletons, this will still be true, right? We don't need to worry about laziness here, so we can just check it.
Yes.
Okay, now this is deallocating. Yep.
Yep.
So we don't care here, we just need to free the buffer if it's existing. This is in new now. Okay. Well, hang on. If we know a size, we probably want to write it. So that feels like the right thing to do. Where are these coming from? These are coming from decoding. Because Max char is passed in by the user here. So we can always determine a kind. That seems fine. Size is... Oh, the user requests a size as well. But there's no... because PyUnicode new creates a buffer for the old data and not a surrogate escaped buffer.
Yep.
And that's just the semantics of how PyUnicode new works. We probably don't want to change that, right?
Right. I mean, we need to record the data we have.
I mean, in PyUnicode new, you don't have any data because the user then calls PyUnicode data to get the buffer, which is fine. And if the buffer is already set, this is exactly the API that we want to deprecate, right? If we move forward in this way. But I think for now this is okay because we want to keep the semantics of PyUnicode new for now. It is user says I want to have a native format buffer of this size and this kind, and then we need to just allocate that buffer. It's uninitialized, and the user will fill it later, and the surrogate escape buffer is also null. Yeah. I think that should work. Okay, where are we now? PyUnicode dump. Debugging helper. We need to work out what to do here. So if it's compact, we know that the lazy flag can be read eagerly. The length might be not meaningful yet.
If it's compact.
Well, this is okay.
Yeah.
So this now data could be null, whereas before it was guaranteed not to be.
So this is dump, like the internal information getting thing. So we should always read the lazy data. And if it's not set, it will just be dumped as not set.
Yeah. So hang on. So data will be, because that's a pointer, format the pointer. Is that right? %p?
Yeah, I think so.
So that will just format as like null, basically.
Yeah.
So that's okay.
Yeah, but instead of UTF-8, we want to call it surrogate escaped.
Yes, and that's okay, because again, if the surrogate escape buffer is not present, then we can do that. And the same... Hang on. But is there a corner case we're not reaching here?
It doesn't really matter.
Okay. It's a debug
If you
helper, you'll
call
say.
dump and don't see the data you want in the dump, then well, you add it. So this is a
We'll change it later. Sure.
short warning.
Okay, we'll call it. We'll just go for lazy length as well then, and see what we get. This is going to be unfortunate because it's calling PyUnicode kind, but yeah. Okay.
Yeah.
Something like that, probably. But if we're testing for now, it's probably fine.
Yeah, we need to have some value for kind that tells you not filled yet.
Like, I guess we just write -1 or something, right? Or
Just probably.
yeah.
So the internal values for kind are 1, 2, and 4.
Yes.
So we just use 0. It's
Uh,
not filled in.
sure. Yeah. So we could have. Yeah, we need to change this function though, maybe to not eagerly fill or something. Like no decoding complete or something. I don't know where it's filled from. It's called from in the copy function as well. We'll come back to that. It probably won't stop like a first pass prototype from working. Okay, so this is now functions wrapping macros for use in debugger. Okay, so that's just so it's creating a symbol so that you can inspect the data, presumably. If debugging. I'm just going to rename this and assume it's fine. And the same here. Because I think it's just wanting to look at the buffer.
Right.
Now we're resizing the buffer. This is to do with the old code paths. I guess we just leave it. So, well, hang on, but lazy length could be 0, and there might not be a kind.
So yeah, resizing is for the old code path. Maybe just assert
it's
that
only used here in Unicode resize.
Yeah, that's something we want to deprecate.
Yeah, because hang on, what would the problem if you tried to call resize on one of these surrogate escape buffers? It makes no sense, right? Or if on one of our Unicode paths, because strings are immutable, and we're aiming for an API where you write it once from something efficiently at the beginning, and you don't expose all the APIs for like, oh, I'm going to create a partially initialized string and then fill it in and resize it and all these things. So we can probably have an assertion, as you say.
Assert that UTF-8 is not filled in.
Well, it frees it here if the buffer has been allocated on the old code path. What's the new? Is it so bad if we do this for now? Hang on, does data any fills the data? So could we just do this for now and move the initialization up? And that way, when we get here, we're guaranteed to have filled the old format. And users should only ever be doing this with old format stuff anyway, so we should be fine.
Right.
And that's probably okay for now. Then everything else, I think, should just
flow. To be
flow.
defensive, we can fill in the old representation
Yeah,
and yeah,
which happens in here.
yeah, okay, yeah, looks good.
So then it should flow through. I think we probably need to, uh, if it has a surrogate escape buffer, we probably want to clear that valid UTF-8 flag here, because it's deinitializing it to assume it's
Do
not.
we want to clear the UTF-8 buffer entirely?
Yes, that's already happening here, right? Like it's doing pymem3, it's setting the length and the thing to null.
Yeah.
And I think we also want to set clear all the state, because it's being resized. So I think that's probably just the addition there.
Yeah, so if we add an is invalid UTF-8 flag, that should also be cleared.
Yes. I guess it depends
so maybe
whether this is 2 bytes or whatever. Sorry, you were going to say?
Yeah, maybe let's add that flag right now, just so we don't forget to add it here.
Do you prefer having 2 reverse flags like this? Because they seem a bit unfortunate, right? You can't ever have both of these true.
True.
So would you rather have, say, UTF-8, for want of a better name, something like this, where we use a 2-bit flag, and then we can have like 0.
Then you need an enum to describe what the values are. It gets a bit tricky. I'd rather have 2 flags.
Okay. Can I suggest that rather than flags that are the inverse of each other, we can have something like this instead then, where like this, where we have one flag that says, oh, we've done the check, and then we have another flag that's true false, which only makes sense to check after the other flag's been checked.
Why is that better?
Well, I guess we could, right? We could have is invalid UTF-8, and then the problem is that there is a state where what happens if both of these are set to 1? Like, it just doesn't make sense.
Yeah, that's an invalid state, yes.
And so I guess my thinking is that having it this way, the rule is you never read this unless this is 1.
Right, so you have 2 states that mean the same thing, pretty much.
It's encoding the same thing, and it's probably slightly less efficient as runtime, I suppose, because if you want to check this flag, you need to read another flag first. It feels easier to reason about, maybe? Oh, I could go the other way. Should we just do the 2 flags as you suggest? Yeah.
I can see the Rust thinking behind this. Never have.
Yes. If I was in Rust, I would have. Just completely writing Rust syntax now. It would look like this in my structure, right? And then the Rust compiler makes this two bits for me, and it encodes 3 states. That's exactly what I want. But we're not there.
Yeah, if we had that, it would make sense. Yes, but I think the is valid and is invalid. I mean, those are the questions you want to ask. Usually.
Yes.
I mean,
and then
we'll see how this gets used. But yeah, this makes more sense to me.
Yes, I suspect that what will end up happening is that then the question is if they're both 0, then you don't know. So
Yes.
you probably end up getting fast paths where if one of these is 1 in a particular environment you care about, then you can just read the 1 value. And if that one comes back 0, you have to check the other flag, and if not, then you have to do the slow path. So
Right.
So you'll end up doing 1 read on happy paths and 2 reads on unhappy paths. So it's maybe like a
So
little
there's
bit more
also
efficient.
there's the very happy path, which is it is valid UTF-8 and we know it, right? So
Yeah,
that's what will usually happen in a sort of performance critical loop, right? Then
that's
there's
true.
the less
Hmm.
happy path of us not knowing what it is. So you've probably already checked if it has the fast path, and
Yeah,
now you're checking
yeah.
it doesn't have this. So you check it is invalid UTF-8. Uh,
Hmm.
and if that is not set, then that's uh, so if that is set, then that's probably the least happy path of all because you typically have to raise the appropriate error,
Yes. I
which
wonder if rather than having this on the state, there is a way that we could have. I'm just going to use PyObject pointer here. I don't think it really is. Um, something like this, we wouldn't actually want to cache the exception object, right? Because of things like tracebacks. But maybe there's some structure we could allocate which caches the decode error so that in places where we need to, then if this is null, we haven't got a decode error. It would be kind of like the
uh,
invalid UTF-8
now
flag,
you're
but
optimizing an error case. I can see why you want to do that because you want to avoid work, but this is the error case.
yes. I
Uh,
guess,
I
what am I
don't
thinking?
think we need to optimize this until much, much, much later.
Okay. I mean, yeah, I'm hoping that there's like a small structure which we could store, which is like 40 bytes or something that we allocate somewhere that would just mean that we don't have to go redecode each time we want to raise the invalid error. Like the byte position, and then that's probably it, isn't it? You just need to store the byte position where there's an error, and then you could reconstruct and decode error from that.
Yes.
Which should be pointer sized, but this has the upside that it doesn't make all the allocations bigger. So
Yeah. Let's keep this.
we'll keep this for now, and we'll not have the error cache. Okay, so we'll do that. So this makes we should go back to where we were. I guess we can probably jump by looking at the error we were looking at. No, we were looking at. Oh, we were here. We were going to set this flag to 0 as well now. Okay, that's straightforward enough. Where else did we set this flag? We could change it here as well, just while we're here. Yes, because we could probably do the inverse case in that. Okay. Right, let's go back to this code, which we were just looking at. So in resize, we have it that it now will opportunistically allocate the native format. It will clear the surrogate escaped buffer and clear the flags. So that should work fine, even if it's unfortunate if we created it using the new format and then went back to the old code paths of resizing and manually writing. But that is what it is.
You shouldn't really do that.
No, I mean, I guess the long run will be get rid of string resize operation because it's
Well, that's part of the whole allocating the string and
yeah.
modifying, which we're trying to
Oops.
get away from. I see it's
Yeah.
not documented as part of that suite of functions, which bothers me a bit, but uh, Yeah, very good.
It's just public, is it? But is there in the CAPI doc PyUnicode resize?
Yes, yes, it's public. It's been there.
And it's in the stable ABI.
No,
uh,
no. Is it? Oh, it is.
I mean, PyUnicode new will be as well, I assume.
Well, we do not have to optimize this.
Hang on. Surely PyUnicode new is not in the stable ABI.
And that's a
That's
good
strange. Well, yeah, that is good. Anyway, that's a bit of a diversion. Sorry, let's go back to the compiler errors where we were. Okay, so now what function are we? We are in PyUnicode resize
I
compact.
see. So PyUnicode resize gives you a new string.
Oh,
Yeah, it gives you a new string and decrypts the old string. So you lose the reference to your old string, and you get a new one. And in case that would delete the destruct the original object, the memory gets reused. And
wow,
this is the
okay.
internal function for the case where the original object is getting reused.
Yeah,
You have the
okay.
assert.
Yeah, okay. Okay. Fine. It sounds like this will work, but we just don't want to. Yeah, okay, so these are the different cases for resizing. So now we're looking at resize compact. So we have a compact object, and we've already said that for compact objects, it's guaranteed that the data is there. So I think for the compact case, it's trivial, and we can just eagerly get the data. So PyUnicode lazy length, and it's doing the same thing where it's now clearing the UTF-8 state, or the surrogate escape state. I have a question for you. We're seeing this pattern come up for the second time right here, and is it worth pulling it out into a function? Probably not, because it's probably only happening in these resize pathways. Because even on deallocation, we won't want to set the flags, whereas here we need to set the flags. Is valid UTF-8 is false. We'll do the same for is invalid UTF-8. And that looks good.
I think it's int rather than bool, so set it to 0.
Oh, yeah, sorry, it is. Because it's 1-bit state. Okay. Here, this is now lazy length, and I think we just fill it in as it was, and this function looks like it will probably work. Let's... Okay. We might have a build that's going to hit linker errors, and we'll need to then go do the hard work of actually figure out how the algorithm works. Oh, no. Oh, no, is that... Hang on. Why did that take so long to get to that point?
Oh, you changed the header file, so everything needs to be recompiled.
Oh, okay, yeah, that's why it was slow. We got excited for no reason. Okay, using Unicode fill invalid. Fill the data of Unicode string with invalid characters to detect bugs earlier. Okay. Where does this happen? This happens in resize. Okay, so there is no surrogate escaped buffer here. This is the resize in place, so the same case has just happened. And then here is PyUnicode new. So that all the cases where this is happening... Oh, while we're here, do we need to set the new flags in PyUnicode new? Probably, because otherwise they're uninitialized, right?
Yeah, we need to set them.
Okay. do we need to do that in from surrogate escape on new constructors or other ones? I've gone a little bit distracted now. Let's assume there are bugs for later. I'm going to write it here.
Oh, you scrolled a bit too fast.
I couldn't find where the other constructors fill in the flags right now.
Yeah, maybe we want a function to clear all the flags later.
Yeah, I figure if I've just put this fix me here, then at least it's somewhere we can find it later and go hunt for constructors when they're a potential problem later. Okay, so back to here. Unicode fill invalid. We just saw that it's only used when there is no surrogate escaped buffer allocated. So we are taking some old length or some length and we're just filling it. So hang on. Oh, because we know how far. This is just an optimization on length checks. So we already have the data there, so I think it's just okay to do that. And in fact, PyUnicode kind is going to force it to be filled anyway. So we can just do this.
Yeah.
Let's do.
Can you add the curly braces again?
Sure thing. We didn't actually change the if.
Oh, we didn't.
No, we changed the line just above.
Okay. Well,
I can still clean it up if you like.
Yeah. I mean, if it'll end up in the same diff block, it's better to change it.
Yeah. Okay. Fair enough. This is just another get ychar size.
Size
Is used in two locations. One is as ychar, which is going to ychar is what, UTF-16 in this context?
Well, that depends on the platform.
Oh yeah, of course.
Either UTF-16 or 32. We probably want to convert to like the Python internal and representation here.
For now, yeah. Okay, so and then where's the other one? It's the same thing, just with as ychar string, as ychar. It's just about what the output format is, and in both cases it's called get ychar size. Okay, so I think we should probably just call our fill data or abort function here, and then we can go and call lazy length, and we know we've got that. Why are the errors jumping around like that? It would be nice if we got more than one at the same time. Okay. Pad. Okay, this is modifying.
Oh, this is centering and left filling and right filling.
Yeah.
So just fill it in. Or abort.
I think PyUnicode get length already fills it, so I suspect for all of these it might already be filled, but yeah, okay, we can just assume it is. Perhaps. Well, we could just use the symbol to. We could use this symbol instead, couldn't we? PyUnicode get length.
Just call the function explicitly at the beginning. That's.
You prefer to do that?
Read.
Just here. Yeah?
Yeah.
No, this can be.
So calling this function also shows up in the diff as maybe something to optimize later.
Yep. Yep. This seems strange, right? Because this is doing padding. Oh, right, because then if there is actually work to do, it's doing Unicode new and doing some writing. So
Yeah.
we are the new output will not have the surrogate escape buffer. We might want to do something to pad the surrogate escape buffer directly and not ever do the existing code paths. But that's
Yeah,
going to be interesting stuff for another time.
definitely.
Okay, great. We hit this kind of stuff before. This is some sort of static data. We're going to have to change a header, so we'll rebuild. There's state fields missing here. Do we have to fill these in as well? Hang on. If it's ASCII,
so yes,
then
it
this is
valid.
1, and we can put the other one is invalid UTF-8 equals 0.
Yeah. Technically, you can leave out the 0, but yeah, this sounds good.
Yep, okay. We have, well, a long time before we get to an error. Nope, here we are. Dump ASCII.
I mean, if we were trying to save bits, we could fold the ASCII flag into the valid UTF-8 flag.
Oh, interesting.
There are 4 options, right? We don't know, or it's known ASCII, or but yeah, that's probably for later.
Because if
We're
it's
not really running out of bits here.
yeah, because if it's valid UTF-8, it is definitely ASCII. No, other way around. If it's ASCII, it's definitely UTF-8. So if the ASCII flag is true, we don't need to check is valid UTF-8 at all, is what you're saying.
Yeah.
So then, yeah.
But the thing we have now is probably better. I mean, there are even more invalid states to have, because if it's ASCII, it cannot be invalid UTF-8.
Yes. So you know what it feels like? It feels like there's a new kind enum which has got kind unknown, kind ASCII, kind UTF-8, kind surrogate escape. four states, 2
Yeah.
bits. And
Well, it's
and
kind
then
of there are kind of overlapping concerns as well, because our flags are concerned about the contents of the buffer,
yeah.
but the ASCII flag is also concerned about the storage format, right?
Yeah. I thought that there was a compact flag which if it
Oh
was
yeah,
ASCII,
there's a
you
compact
also
flag
check compact.
and an ASCII flag. Yes.
So we could have it that, if it's compact ASCII, that's how you do this, right? Whereas if
Yes.
it's this could be like new kind, or no. In our imaginary new world where we only use 2 bits, but we could come back to that later.
Yeah, definitely.
Okay, so let's think. This is dumping the ASCII thing. Shall we just fill the data here for now for simplicity?
Yes.
Because this is a debug helper anyway. And then we can just replace the rest of these without thinking about it for now. Okay. I think it might build. Oh no. Remote debugging.
Oh, what is this?
Read Pyster. Read the entire...
Okay, yeah, fill it in at the beginning.
Yeah, that'll do for now.
Redebugging is probably not something we want to optimize.
Oh, hang on. But this is... What? This is symbols not show it. Oh, no, it is showing up. We're okay. But we probably want to do it earlier. But we're doing some funky stuff here where we don't actually have a pointer. We should do, because we have Unicode object, so we could just hang on. Oh, because it's a remote debug, so it's copying the remote memory head. It's copying the state of the remote Unicode object into this space on the stack. So at that point in time, we're going to snapshot whatever that thing is, and then we are... So we can make decisions on the state, but then presumably we're actually going and having to... Oh, no. So this is...
We'll need to read both backwards here somehow.
Can we just make this abort for the moment? Because we don't need it to... We're not going to use remote debugging for our prototype.
Yes.
Yeah, let's do just this.
Yeah, to do. Let's figure this out later.
And because we're going to need to change this whole machinery to decide what to read and copy into a local string, I guess is what's going on. And that's going to be completely broken by changing things. We rely on the remote process sharing this Python version PyASCII object layout. So we're going to get completely... This is going to be painful, because if you want to remote debug across Python versions, I don't even know what happens. I haven't tried the remote debugging stuff, so I have no idea.
I don't think we can do that.
I mean, presumably there is some way that we can know. So we might have to do some backwards compatibility shenanigans in here, depending on what the remote debugging needs. It looks like this has still failed to build. I'm just going to change this for now.
Yeah.
And
makes sense.
Move on. And now I think we... Oh no. I'm a bit lost. There's more errors up ahead? No? Let me just do this again. We are getting... It's just the undefined reference? Yeah. PyUnicode fill data or abort. And maybe PyUnicode is valid UTF-8. So we've just got the algorithms to fill in. And we've got 10 minutes left to do that today.
All right. So maybe this calls for a git commit.
Yep. Okay, sure thing. Well, no, not fully functional. Let's call it initial
down to micro errors.
Shape of solution minus new symbol, symbols, something like that. We can push that. Right, we have 10 minutes left on what I was on the time I had for doing this today. So we could play around with those new implementations for a moment, or we could wrap up here and look forward to getting on with those next time.
Yeah, let's play around with them.
Let's make use of the time then. Okay, let's.
We're time boxed for 10 minutes only.
Yeah, so we've got PyUnicode, fill data, or abort. Oh, I probably don't need to do it this way. I can probably, now that I've got my... Oh, my ID's done.
Probably not find the implementation of that.
Anyway, I was hoping it might take me to the definition, but it looks like it didn't want to. Anyway, we've got it here from the search. So we can go into, oops. What have I done there? I've just unfortunately reset Zoom. I think that's where we were at before.
So I think you want to go to the current implementation of PyUnicode from UTF-8 and size.
Oh, yes, we were talking about this, weren't we? Because it's called from string and size.
Oh, yeah, okay.
And it does the UTF-8 decoding. And we wanted to split this up. I remember now. Oh. I thought I just copied it. I didn't copy it. That's what I wanted to do. So now we have the symbol here, which we can begin to implement, I guess. So you want decode UTF-8 stateful. This is taking the buffer. So we want to
so decode UTF-8 stateful takes a buffer and gives you a string.
Gives a new one. And the difference is that we want to split this implementation so that it will first... Oh, hang on, let's think about this. It will have an existing string and it wants to fill it in. So
now we want to take this implementation and make that into the fill function.
Yes.
And we want to replace all of this by creating, like storing the data directly and then validating.
Yes. So, yeah, I suspect you're right. Rather than doing this symbol now, let's split this. Let's refactor here. So we have Unicode decode UTF-8, which first does some checks. And these are... now that's an interesting question. Suppose that we ended up with a surrogate escape buffer that's empty or one character. We probably don't want to ever get to that point. So we probably want to, if the user is constructing one of these with a 0 or 1 byte input, immediately jump to the singletons.
Yes.
So those will have to go in from surrogate escape, probably. Maybe we can do that now.
Yep.
Let's think about this. This is not got any of those checks at the moment. It's just copying the memory in. So we would like to do those checks before we do PyObject new. We also have from string and size, which doesn't do the checks because they're currently in decode UTF-8 in here, and I think that from string it just does
So
Sterling and then does the same.
Yes. So in the Unicode from string and size, so this should call Unicode from well, the function right above. What's the name?
From
Unicode
surrogate
from
escape.
surrogate escape, and then it should check that
Uh,
we have like the ace.
oh,
ASCII.
interesting. I see what you mean. Basically just hoist this up to go into here, or hoist this to go into there.
Yes. And the
Right.
implementation that's currently there will put that into the fill function, like the fill or abort.
Yes.
I just
So that's going to
comment-
change existing
out
code
what-
paths, which I
Yes.
guess we want.
Yeah, this is what we
So,
want. So
because we added this
comment
new
out-
constructor.
Call this function there.
Yeah. So where are the call sites for decode UTF-8 stateful? They are. Oh, interesting. Oh, because it's an external symbol.
It's public. Yeah.
Yeah. Okay. And it's used all over Unicode object. Decode UTF-8. Okay, different decoding functions. That all makes sense. From we'll think about that later. Okay, but okay, yeah. So in these ones, at least, we can change this to call Unicode from surrogate escape, and we need to potentially return the singletons. So this is PyObject. Maybe.
No, so I think you're complicating things by thinking about the singletons right now. That's an optimization. We can figure that out later.
Okay, yeah, that's fair enough. So you want to say to do check for singletons.
No. I don't think we need to change. Oh, yeah, check for singletons. Yeah, but the work
Actually
will
fix
come
me.
in the function below. Unicode from string and size. Just comment everything that's in there right now out and add a to do because we have half a minute left.
Okay. Or, well, we've only got the tiny diff anyway. We can just come back to that next time. I'll just revert these for now.
All right.
And then we'll come back to that next time. Super. So next time we will, I guess, get a work. Hopefully it shouldn't be too hard to refactor these algorithms to do the piece we need. And then we should be able to have a fully working implementation of CPython, fully working, that does this. And we'll have to see, well, once we've done that, then we can start doing things like, I guess, the next steps will be measuring what the performance looks like when working with UTF-8 data to work out whether going down this road is going to be worth it for the ecosystem, right? Hopefully it should be.
Yeah. Well, we need to do enough optimizations to
yes
to make it worth it and not pessimize other use cases.
Yeah, that will be the interesting piece. Okay, great. I will end the stream here then. Thank you everybody who's joined today. We'll look forward to seeing you next time, which I think don't have my calendar on me. That's not very clever.
So last Friday of June is the 26th.
Yes, which I think should work for me.
Yeah, works for me as well.
So we will look forward to seeing you all on the 26th of June then. And for now, where's YouTube? Here we are. Take care, everyone. See you then.